Okay, the promised analysis video. Um, so I've got now my information about the search coil. Oh yeah, that's the resistance of the precision resistor. Most of you are just going to use one. And that was my measurement of the V peak to peak across that resistor. And so it's the voltage divided by the resistance, and of course divided by 2 because I want the amplitude. This is simply something you look up, the permeability. Okay, so we need to, this is our fit function, and we've already set that up. And but notice mu sub 0 n times I 0 over 2a, so that's the coefficient. Let's see if we can, it's tedious to put symbols in there, so since it's obvious what that says, I let it be. So I'm just combining the needed numbers. Okay, so I've got my data points here, and out to 25 centimeters. I don't know. I didn't think that was enough, but I forget how far you could go. Well, we'll find out. So now for the search coil, and let's see where that formula went. Here, yeah, search coil. Okay, and so I want to zoom back in. View. Oh no, zoom to the selection. There we go. Okay, so this is maybe experimental here. So that's the measured V amplitude. Then 2 pi, the number of turns in the search coil, R and S, and then that gets me the area with that formula. In case you don't have it already. It's supposed to be in a pre-lab, but maybe I missed it. And the frequency is the line frequency. And so once again, I just decided to create the 1 over, well, this is just 2 pi ns a times f. And I can format that to make it look a little prettier. Let's see, home menu. And I want that to be a number. And there we go. Here, yeah, scientific. We probably want less decimal places. There we go. Make it look pretty. Okay, so there's my, these are the Z measurements. Then I convert it into X, and then that's X divided by the radius. And done that over here. Whoops. Oh, well, no. Never mind. Oh, I think, right, we did it in reverse for this table. Okay. And then we have our V peak to peak. It's just data we wrote down. Probably these, these are 88.4 millivolts. And now I want to construct, might be experimental, and That's quite a few decimal places. And we'll just cut it down, make it look a little neater. Same thing here. Well, this one has that extra decimal place. Alright, so we'll turn this into scientific. And there we go. Okay, so it's the VP, the amplitude. So we've got to divide by 2. There is K15, that's the V peak to peak. And this is it's a constant because all of these are constants. 2 pi n sub s, a, and f are all constant. So I just do it once up here, and then I use the dollar signs to create that. Its absolute addressing, it always refers to that cell. And then I take the fill handle and drag it down. Oh, excuse me. And then I didn't have you guys make plus or minus, so I just use 3%. So it looks exactly the same, except for that 0.03 there. So I'll leave that a bit, but of course you guys can just stop the recording if you like. Alright, got my nut bar. My lunch bag. Even have my name stapled inside my shirt, like when I went to kindergarten. Alright. Now, oops, we need a fit line. And that is going to be that equation, and I have it here. So separate column for f of x. And maybe I'll do that because it makes it easier to. You have to type in everything in one line. So I can copy that. Now, you just got to be a little careful now. It has to pick up the x value, which is J15 in my case. So I've got to change that to J. And then take the fill handle, and I got it. Okay. And we got the res squared, and we're going to use the chi-squared as well. Okay. Well, first of all, let's make our graph. And I have to, let's see, where do I want zoom button? View menu, 100%. And I have to admit, I forgot which is the x-axis. And it's the z values. Interesting. Oh yeah, of course. But um, oh, it worked here. This is like first thing I'm doing is I arrive here, so should have done a little reading first. So find the z values. Well, this will make sense, right? Because that's what we see in the real world. Let's see what happens. Okay, so we got this, and we hold down a control key, and I suppose I should go ahead and zoom in. Of course, then I've got to make room for the graph, but we'll get there. Okay, so there, and hold down the control key for B experimental, and then we say insert, and we want to scatter plot, and there we go. And I'm going to add the error bars. So we got, when we see we've got, since the graph is highlight, we see chart design and format, add a chart element, and remember we do this before we put the fit line on the graph, because that way we don't have to do it twice, because it doesn't give us the option to put the error bars in only one data series. So the X ones, the easy ones, we'll do first. And remember, the Mac people have to go up here. And let's see, we want fixed value. We want it to be 0. Then, excuse me, next is the Y error bars, and hopefully I can move that. Yep. But we lost where we were. Okay. I needed to make sure that the appropriate numbers were visible. Specify, and so we got here, and we've got the same ones. I hope I picked the right ones. We'll see. Oops. Okay. There they are. Oh, by the way, if you just put a plus minus here, Excel will complain. So you need to go to the upper left of your keyboard, and you'll see this. It's called a diacritical. Looks like an apostrophe. Oh, wrong one. Okay, maybe it is an apostrophe. So there's no computer science majors, but next to the enter key is the apostrophe, and you see that it disappears. It's what's called an escape character. It's a special character. You can't use it anywhere in any expressions. And then it allows you to, it tells Excel that the plus minus is a text string. Well, it's a string. String characters are text. A string is text. Okay. All right. So now we can add to this. So select data. I want to add, and the title is to fit, and the x-axis is the z values. Make sure only select the numbers, And the Y values are the fit itself. Okay. And of course, they're going to lie. Oh, something went wrong. What happened? What did I do? Select data, edit. Yeah. Yeah. Yeah, what's going on? Fit. All right, there they are. Edit. And, yup. And, yup. Okay, let's see what happened. Yeah. Single coil. Okay. Let's, oh, let me pause for a moment. Well, duh. I forgot that this is not the actual fit. This is uh, the values of f of x. So we got to insert, and we shift the cells right, and this is actually fx, and this is the fit, and that's equal to our coefficient here. Oh, this coefficient times f of x, and yeah, so equals this. Oops, no, escape equals the f of x value. No, I think I clicked on the plus minus times this one, and I need the dollar signs. And yeah, now it looks the same. Whew. Sigh of relief, huh? And now they're quite similar. A little bit off, obviously. We'll work on that. So select data. And see, that changed. So we have to change it to here. X values will stay the same. So we just have to change the Y values. And voila. Not bad, huh? Okay. Now we'll want to format that because we want it to be a line. And let's see, solid line, marker options, none, and back to the line. I want that to be, I like red. Oh, what happened? What's going on? Oh, we're still under the marker button. Okay, line, and I want to make it smaller. Okay, so I notice that it's kind of kinky looking. That's because it's yeah. One could argue that I could use this, but I can only do residuals with data points. So what I can do is I can change the chart type, and let's see. Well, this will stink because now I've got to go back and get rid of that blue line. No line. And the error bars disappeared. Oh my. So I'm going to blow that off because I don't want to deal with the work I have to do. Sorry. Okay. So we don't have any fit parameters yet. So we have to come up with some. So we've had this scale and offset. So you multiply it by a number, and then an offset number moves it up and down a little bit. That, in this case, is vertical offset. And I was thinking that maybe we could do 3 fit parameters, a vertical offset and a horizontal offset. And we could see what could happen, huh? So fit parameters. It's odd. Font. And hit enter. And we could do something clever here. We could merge and center. So we're gonna say scale. Oops. Scale. Vert off. And horizontal. Well, horizontal offset's gonna be a little tricky. Cause then I'd have to. Oh yeah, I know how to do it. Okay. And then we have the sum of the res squared and the sum of the chi-square. Okay, so first of all, we can just copy these two numbers to start. Well, maybe you don't have them. Okay, so 0, oh, put 0.9, oops, and 0 for the offset here, and 0 for the offset there. Okay, so now we have to put that in there. Okay, so here's the fun part. This is the x value here. So to get the horizontal offset, we have to put that in here. So that changes the value of the x-axis number a little bit. Plus, and the horizontal offset, hit F4. And I've already got the parentheses there. Okay, so oops, F4. And now the vertical offset, no, first of all, the scale factor is times the whole thing. And F4 once again. And now I want to add the vertical offset factor and my F4 again. Okay. So now, I notice the graph changed a little bit. Neato Kino, huh? So what happens if I do 0.95? Not bad, huh? Okay. So, let's make these numbers for the time being, and we'll see how it goes. So this equals the data minus the fit, and then we have to square it. Oops, I forgot to put the 2 in there. Um, and this is simply the res squared divided by the plus minus squared. And there we go. So we can fill both of them in at the same time. Okay. So let's see. This equals sum of these guys. And I don't believe it, but oh, 0. Oh, of course, it's because it's too small to be represented at 2 decimal places. There we go. Pretty darn good, huh? And equals sum of the chi-squareds. And interesting, that becomes a number. Okay. Let's put grid around it. And okay, that works for now. It's pretty dim. Okay, so let's see what the solver does for us. This is sort of different fit than we've done before. And so we want to minimize the sum of the chi-squares. And we don't want to limit them just yet by changing these 3 parameters. Okay, let's cross our fingers. So it failed. Okay, so we don't click, well, maybe cancel, but if you said OK, the undo button doesn't work. So we want to say now restore original values. Okay. Let's try solver, but now we'll just stick with the original scale and vertical offset and solve. Oh. What happens? Okay. Wonder what happens. Let me check and see. Oh, I just did it by hand here, I think. Okay. And I scaled it to reticles. Oh, and the offset's not involved. Interesting. Okay. Okay. I did this fit with the double, this data here. And it came out quite nicely. So, let's see if this thing, where are the fit parameter tables? There's the sum of the residual squared. Oh no, that's not it. AF31. Oh, it must be down below here. Oh, we have to cancel this because I got this in the way. Oh yeah, so sum of the res squared, sum of the chi. I did this quick and dirty. This we're going to learn about. So let's look at the fit values. So, yeah. That has the scale factor and the offset. And yep, there's the thing to minimize. And where are the? There they are. There's the things that we vary. And so we solve it. And right. So it's fine. Okay. Let's see what mistake I made. V17, V16. So that's V16. Yeah. And yeah, I didn't multiply it. Alright. Alright, well, let's see. If we have vertical offset of point 121. Yeah, that worked. And let's check here again. And did I do it? Oh, okay. Make it positive, non-negative. Well, we could try that. I don't like it. So, oh, we're in the wrong place. Let's try this. And it still failed. So, yeah, I dragged it down, right? And then, okay. In this case, I have it. So, well, I better pause this. Well, there's something in there that I did wrong and I don't understand, but that's okay because we can just do it the old-fashioned way. And so 0.98, and we see the sum of chi-square goes down. 0.97, and it went down some more. 0.96, went down even some more. And let's see, 0.95. Ooh, not bad, huh? Now, 0.94. Ooh, even went up. I mean, got smaller. Coolio. And 0.93 got bigger. So .935. No. 0.939. 7.8.94. Okay. What about 0.941? Ooh, went down even more. Okay. That's the best we can do apparently. Because solver is deserting us for some reason, and that's fine. Okay, so now what we're going to do is we're going to do the R squared test. And what we need is the sum of SS total. And for the life of me, I can never remember what that is, what it stands for. And what we need is, now to construct that, and let's, oh, we got Wikipedia up already. And so we got, what is it? Oh yeah, R squared coefficient of determination. I think that's it. Right. So do we have a good fit? So what we do is we get the average value of the data, which means that that would be a flat line, a single value. And then we look at the residuals from that. See, these are the residuals, and it's residuals squared, remember, that's why they're boxes. And so these things have areas, right? We sum up those areas, and we sum up those areas. And what's not up there, that I don't have my stylus ready, and you see there's the average here, and so the residual sum, oh, that's the, yeah, and the total sum of the squares here is the data point minus the average and square it. So that's the red areas. And then we divide the blue areas by the red areas. So you see that if the fit is good, the blue areas will get minimized and the red areas will get maximized. So that sum here, this fraction will get very small. So this R squared will approach 1. And this is more important for, like in physics and engineering, our fit parameters are pretty much known to us, like this formula for f of x, for example, and we can separately test these equations. But we're trying to demonstrate that that Faraday's law works, right? We didn't need Faraday's law to derive this one. This one. And we also know and Faraday's law is about changing flux. So it's this thing, if this fit equation gets a good R squared, then that means Faraday's law, which we use to derive this, works. Okay. So we got SS total, and we need average, and that equals the IVE average of, don't forget it's the data points, oops, wrong button, again, close the parentheses, then this equals, oops, the data minus the average. So make sure that we put dollar signs, and then we have to remember to square it. And then we fill it. And then we say, all right, equals the sum of these. And did I do it right? Yeah, okay. And now we have r squared. And this equals 1 minus, I'm using parentheses just to be safe, the sum of the residual squared divided by the sum of the total. And then close it, and that's pretty darn good. If you get a oops, I don't want general, I want a number. Wow. Well, we need 4 decimal places. There we go. It's always quoted as 4 decimal places. So that's a ridiculously good fit. So this scale factor is simply because we're making up for errors, that experimental errors that we can't identify just yet. But as long as it's close to 1, we're happy. Let's see if I make it 1. Oops. Okay, r squared is still not bad. All right. Very good. So we'll stop this because it's such a long video. But I went pretty slow, and so hopefully it's not going to be too hard to follow along.